Hi everyone. So today we will look at this past year paper, October November 2024, the variant 2 version for pure mathematics 3. So question 1, expand this in the ascending power of x up to and including the term x squared. So you just use binomial expansion. So before you do the binomial expansion, please remember that the constant term has to be 1. So you need to factor out number 9. So you have value 3 multiplying outside, and then 1 minus x divided by 3. Okay. So until this point is quite clear, you can just expand using the binomial expansion. The first term is 1, second term is nx. So you have minus 1 over 2 multiply with x over 3. And then the third term will be 1 over 2 minus 1 over 2. The whole thing you divide by 2. And then you have minus x over 3 square and so on. So after the expansion, you will have 1 minus x divided by 6 minus x squared divided by 72. And finally expand, you multiply everything inside. You have 3 minus x divided by 2 minus x squared divided by 24 plus so on. So this is the expansion. Question 2, by sketching a suitable pair of graphs, show that cotangent 2x equals to secant x has one root within that particular interval. So you have to remember the graph of cotangent. So cotangent basically you have so let's look at the tangent graph first. So tangent graph looks like this. So this is pi over 2 and then this is 3 pi over 2. So then it is obvious that over here for cotangent graph this will be the asymptote, and then at pi over 2 you hit 0. But because you have this particular 2 here, this means that you compress the graph by a factor of 2. So it means that from 0 to pi over 2 you are actually covering up to here. Okay, so here this is tangent graph. So if it is a cotangent graph, so at this point this is asymptote. So the asymptote will be reflected to 0, and then there is another asymptote over here. So this portion of the graph is positive, this portion is negative, so your graph shape should look like this. Alright, so that's why this will be pi over 4, and then you can draw something like this. So this will be your cotangent 2x graph. And then you have secant x. So let's do the same comparison as before. So if your cosine graph is like this, so there is no compression. So from 0 to pi over 2, this is the region that you need to sketch. So then the same thing, this will be 1 because 1 over 1 is 1. And then this portion of the graph is positive, so it curves upward. So this will be pi over 2. So the other graph that you need to draw is basically something like this. So this will be 1. This is secant x. So that's how you sketch these two graphs quickly. So as long as you show this, that will be correct. Show that if a sequence given by the iterative formula converges, then you converge to the root in part A. This is just a 1 mark question. So basically what you need to show, you can either show from the equation going back to here, or you can do the other way around. So let's do the other way around. Cotangent 2x is secant x. Cotangent is 1 over tangent 2x. Secant is 1 over cos x. So it means that tangent 2x is cos x. Then you do arctangent, and then you divide by 2. So here you effectively show that the equation given above, the iteration formula given above, is the same as what you have derived. So that's it. Yeah, there's nothing else to cover. Question 3, you have a square root of this, can be expressed in the Cartesian form. Form a quadratic equation in terms of x or y, and then find the square roots. So what it means is basically you need to write x plus iy square equals to 6 minus 8i. The square root of 6 minus 8i is x plus iy. So you square the left side, you get x square plus y square. Sorry, not plus, it's a minus. Plus 2xyi equals to 6 minus 8i. So you comparing between the real and the imaginary parts. So you have x squared minus y squared equals to 6. This is equation 1. Equation 2 is 2xy equals to minus 8. So over here, I would prefer to work with x. So I substitute y. So that will be 4 over x. So that will be equation 2. So substituting 2 into 1, you will have x squared minus y squared, which is 16 over x squared, equals to 6. Alright, so you multiply x squared on left and right. So you have x power 4 minus 16 equals to 6x squared, or x power 4 minus 6x squared minus 16 equals to 0. So then you can do the factorization. Over here I did the quadratic formula. So x squared will be equals to 6 plus or minus square root of 36 plus 4 times 16 divided by 2. So this is either 8 or minus 2. Minus 2 will be rejected because your x has to be a real number. So then x would be plus or minus 2 square root of 2. So then from equation 2, y would be minus plus of 4 divided by 2 square root 2. So y minus plus, because remember that y is the minus of 4 divided by x. So that's why the plus minus sign reverse. So in the end, when you simplify this, you will get minus plus square root of 2. So finally, write down the square roots. So it will be the square root of 6 minus 8i r 2 square root 2 minus square root 2 I, or minus 2 square root 2 plus square root 2 I. Question 4. Solve the equation. Give your answer correct to 3 decimal places. So you have 5 power x equals to 5x plus 2 minus 10. So first thing you need to do is to eliminate the plus 2 on the index. So you will have 25 times 5 power x minus 10. The second thing is to move things around. So let's put 10 on the left side. On the right side will be 5 power x. So then you will have 24 times 5 power x equals to 10. Or 5 power x is 5 divided by 12. So taking the natural logarithm, you will have this. So x will be minus 0.544 up to 3 decimal places. Question 5a. You are given a complex number. Find the exact value of argument, the argument of u. So what you would do is, first, u is given by this cos pi over 7 minus I sine pi over 7. Then you have cos pi over 7 plus I sine pi over 7 power 4. So what you need to do is to multiply with cos pi over 7 plus I sine pi over 7. Then you divide by this. The reason why you need to do this is to make the lower part, you want to get rid of the complex number, so you multiply with the complex conjugate. So once you do that, you find that the bottom part actually becomes 1, because cos square pi over 7 plus sine square pi over 7 equals to 1. So you would have cos pi over 7 plus I sine pi over 7 power 5. And the one inside is just your Euler formula. So therefore, u is actually equals to e to the power of I 5 pi over 7. So therefore, the argument of u would be 5 pi over 7. You have a conjugate, so single geometric transformation. So the definition of conjugate is that if you have, let's say here is xy, definition of conjugate is here, x minus y. Alright, so the transformation is a reflection on the real axis, which is our x-axis. So that's your transformation. State the exact value of argument of u. Argument of the conjugate of u would be minus 5 pi over 7. recall that the conjugate, you just put a minus sign in front of I, which is why it is minus 5 pi over 7. Question 6, you are given this particular equation, and then the y-axis is ln y, x-axis is x. So first do the transformation. Ln ay equals to ln b power x. So this is ln a plus ln y equals to x ln b. So ln y is equals to x ln b minus ln a. So this is your y, this is your m, this is your x, this is your c. So after that, just substitute the points to find the value of a and b. So at this particular point, 0.5, 2.24, you would have 2.24 equals to ln b multiplied with 0.5 minus ln a. So let's set it to be the first equation. The second equation will be the second point, 3.4, 8.27. So you have 8.27 equals to ln b multiplied with 3.4 minus ln a. So that will be your second equation. So basically you can do the substitution method. So for my workings, I did the substitution method, whereby over here ln a will be equals to 0.5 ln b minus 2.24. So then I substitute into 2. So 8.27 equals to 3.4 ln b minus 0.5 ln b plus 2.24. So if you simplify everything, ln b is 2.0793 and b is approximately equals to 8. You only need one significant figure, so it's 8. Then you substitute back into one of the equation. So ln a, we know that this is equals to 0.5 ln 8 minus 2.24. So simplify everything, you find that a equals to 0.3. Question 7. Show that the equation can be expressed in that. And given that tangent x is not equal to 0, so you start from tangent to the power of 3x plus 2 tangent 2x minus tangent x equals to 0. So use the definition of double angle formula. You have tangent of 3x plus 2. So I will just write the version down. Is 4 tangent x. 1 minus tangent square x minus tangent x equals to 0. So multiply the whole equation with 1 minus tangent square x. You would get 1 minus tangent square x times tangent power 3x plus 4 tangent x minus tangent x multiplied with 1 minus tangent square x equals to 0. So the next step that you need to do is to multiply everything inside. So you will have tangent to the power of 3x minus tangent to the power of 5x plus 4 tangent x minus tangent x plus tangent to the power of 3x equals to 0. Factorize out the tangent and simplify the equation. So you would have tangent to the power of 4x. Over here, this is negative, but you can change it to positive by removing one of the negative sign. So you should be able to do that by now. So then you would have minus 2 tangent square x and lastly minus 3. So it's either, since tangent x cannot be equals to 0, because it's either the first term or the second term equals to 0. So therefore, tangent to the power of 4x minus 2 tangent square x minus 3 equals to 0. So that's the proof. Part B. Solve the equation. So this part of the equation, the left side is basically this. With your x changed to 2 theta, so you can directly use the identity that you proved earlier. So tangent to the power of 3 2 theta plus 2 tangent 4 theta minus tangent 2 theta. This is equals to tangent to the power of 4 2 theta minus 2 tangent square 2 theta minus 3, and this is equals to 0. So you can directly do the factorization. So you will have tangent square 2 theta plus 1 tangent square 2 theta minus 3 equals to 0. So now you have tangent square 2 theta equals to minus 1. This has to be rejected because tangent of square cannot be equals to minus 1. The other one will be tangent square 2 theta equals to 3. So therefore, I just write here, tangent 2 theta will be plus or minus square root of 3. So now you need to take note of this. This is your solution space. If it is 2 theta, then you should find your solution from 0 to 2 pi. So 2 theta will be equals to, when you find what is the inverse arctangent of square root 3, basically you will get pi over 3. So because you have plus or minus, so you need to find your answer in 4 quadrants. So the first one is pi over 3, second one is 2 pi over 3, and then you have 4 pi over 3, and finally 5 pi over 3. So your solution will be pi over 6, pi over 3, 2 pi over 3, and then 5 pi over 6. So that will be your solutions. Question 8. You have a parametric equation of a curve. Show that dy dx is given by that. Okay. So first thing you need to do is to differentiate with respect to t for x and y. So for x, you need to use chain rule. So differentiate on top, you have 2 tangent 2t. And then differentiate tangent, you get secant square 2t. And then differentiate 2t, you get 2. So the other one is to differentiate y in terms of t. You will have minus 2 sine 2t. So what is dy dx? Dy dx will be dy over dt times dt over dx. So this will be minus 2 sine 2t multiplied with 4. So tangent 2t is sine over cos, so you reciprocate it, you get cos 2t over sine 2t. And then secant square, you will get cos square 2t. So simplify everything, you should be able to get minus 1 over 2 cos to the power 3 2t. So that's what you want to prove. Hence, find the equation of a normal to the curve where t equals to pi over 8. So give your answer in the form of that. So dy dx, alright, at t equals to pi over 8, your dy dx will be minus 1 over 2 cos to the power of 3 2 times pi over 8. So if you evaluate this, you will get minus square root two over 8. So using the m1 multiplied with m2 equals to minus 1. This is the equation for normal. So you will find, for instance, the gradient of the normal would be alright. So you have minus square root 2 over 8 times m2 equals to minus 1, or m2 equals to 4 square root 2. So once you have found the gradient of the normal, you need to find the equation of the normal. So at t equals to pi over 8, x will be tangent square 2 times pi over 8. That gives you 1. Whereas y will be cos pi over 4. I directly calculated it, I believe. So this is square root 2 over 2. Finally, y minus square root 2 over 2 divided by x minus 1. This is the same as 4 square root 2, or y minus square root 2 over 2 is 4 square root 2 x minus 4 square root 2, and y will be 4 square root 2 x minus 7 over 2 square root 2. So that is the equation of a normal. Question 9, you are given 3 points and DC is 3AB. So find the position vector of D. So you start with DC equals to 3AB. And what is DC? DC is DO plus OC. 3 times AO plus OB. Alright. So DO is what? DO would be 3. So AO would be minus 2, minus 1, 3. Plus OB is 0, 4, 1. And then you need to minus OC, which is minus 3, minus 2, 2. So you do the calculation above, you should be able to get minus 3, 11, 10. So this is minus 6, minus 3, 9, plus 0, 12, 3, plus 3, 2, and then minus 2. Yes, you should be able to get that. And finally, revert back to OD. That will be 3 minus 11 minus 10. So the diagonals intersect at point B. Find the position vector of P. So let's say this is your trapezium. Okay, it doesn't convert, so I have to draw line by line. Okay, let's say this is your trapezium. Let's say this is A, this is B, this is C, this is D. So DC is equal to 3AB. So if you draw the diagonals and label the intersection point as P, so because you see the angle of ABD is the same as BDC, and then the angle of BAC is the same as ACD, and then the angle at the middle, they are the same. So it means that this is actually a similar triangle. So you can use this approach to find the position vector of P, which I find it a bit easier. So you know that DC is 3AB. So the value of 3 is very important because that tells you the ratio. So then by similar triangle, 3AP will be equals to PC, or AC has 4 parts. So then so what is AC? AC is AP plus PC, and we know that AC has 4 parts. So let's start with AC. AC is also equals to AO plus OC, and this is equals to AP plus PC as well. So what is AC? AC is basically this AO plus OC. So this is AC. And this is given by -5, -3, 5. Then you need to find AP. We know that AP will be 1/4 of AC because of the ratio. So this is 1 part and this is 3 parts. Okay. So total length will be 4 parts. So if we count from AP, AP will be equals to 1/4 of AC. AP will be 4 parts of AC. So this is 1/4 times -5 -3, 5. Another way that you can think about this is basically AC is equals to AP plus PC, which is 3AP. So that's why you have 4AP. Okay. So perhaps here I can write 4AP. So that's how the 1/4 factor comes from. And then essentially you need to find AO plus OP. That is AP. So this is 1/4 -5 -3, 5. So OP will be equals to this -5 -3, 5 plus OA. So AO, when you move to the right side, is minus AO, so it becomes OA again. So OA is 2, 1, minus 3. So in the end, when you perform the calculation, it should be 1 over 4, 3, 1, minus 7. You should get that. Using a scalar product, calculate the angle ABC. So if you want to calculate the angle ABC, you need to calculate the dot product of BA with BC. And we know that this is equivalent to BA, BC, cosine of the angle in between. So let's calculate BA. So BA would be 0 minus 4 minus 1. So over here I already simplified how you will find BA is actually BO plus OA. So the first term is BO, second term is OA, 2, 1 minus 3. So this is 2 minus 3 minus 4. What about BC is BO plus OC. So the same thing. You would get minus 3 minus 6, 1. So then apply the dot product. So from the left side you would get minus 6 plus 18 minus 4. The right side you will get 29 times square root of 46 cos theta. So cos theta will be equivalent to 0.2190, or theta will be 1.35 radian. Question 10. You have a balloon with sphere, air pump in 40 pi, and then go out at 0.8 pi r. So V is 4 over 3 pi r cube. So let's differentiate with respect to r first, because we are going to need it. So this is 4 pi r square. So dv over dt is given by going in 40 pi, going out 0.8 pi r. So therefore, dr over dt will be dr over dv plus multiply dv over dt. So dr over dv will be 1 over 4 pi r square. dv dt will be 40 pi minus 0.8 pi r. So you simplify all these terms, divide by 4, this will be 10, this will be 0.2. 0.2 is also 1 over 5. So in the end, you should get 50 minus r divided by 5r squared. So that's what you want to prove. Find the quotient and remainder when 5r is divided by that. So this is 5r squared, 50 minus r. So you will need minus 5r to get 5r squared minus 250r. Minus this one, you get 250r minus 250. So you will get 250r minus 12500. So in the end, you will get 12500. So the quotient will be minus 5r minus 250. Remainder will be 12500. Solve the differential equation. So dr over dt is given by 50 minus r divided by 5r squared. So then what you need to integrate, is 50 minus r 5r squared dr integrate dt. So the thing is, you already find the remainder and quotient. So it means that what you need to integrate is this. So the right side already integrate, you get t. So you integrate everything, it will be t equals to minus 5r squared over 2. Okay, minus 250r minus 12500 ln 50 minus r plus c. So at time t equals to 0, r is also equals to 0. Substitute all the thing inside. So you will get that c is 12500 ln 50. So therefore, t will be minus 5r squared over 2 minus 250r minus 12500 ln 50 minus r plus 12500 ln 50. So that will be your final solution. Find the value of t when the radius is 12. So r equals to 12. Substitute to the value above. T would be okay. So over here I basically combine these two together. You can definitely do that. So that's why you can just substitute all the values inside. So 50 minus 12, that is 38, minus 5144, 2 minus 250 multiplied with 12. Solution will be 70.5. There's no limit stated, so you just leave it like that. Question 11. Find the first derivative of fx and then the exact coordinates of the stationary point. So f prime x will be, use your quotient rule, keeping the bottom, differentiating the top, minus keeping the top, differentiating the bottom, and then the bottom part you square it. Sorry. So that is your first derivative. And at stationary point, your first derivative is 0. So only the numerator counts. So that's why write down the numerator. And then expand everything, you will get e to the power of 2x that you can factorize out. you have 4e2x minus 12ex plus 8 minus 4e2x plus 6ex equals to 0. So e to the power of 2x cannot be equal to 0. So the one inside has to be 0. So 4ex minus 4ex get cancelled off. And then you have minus 6ex plus 8 equals to 0. So e to the power of x would be 4 over 3. Or x is ln 4 over 3. You want to find the stationary point. So you also need to substitute what happens when x equals to ln 4 over 3. Okay. So just refer back to the equation above. So you have 2e2x. So you have 4 over 3 square. At the bottom you would have 4 over 3 square minus 3 times 4 over 3 plus 2. Evaluate this, you will get minus 16. So that is your stationary point. That's it, right? Yep, find the exact coordinate of the stationary point. So the stationary point would be ln 4 over 3 minus 16. The last question, use the substitution to find the exact value for that. Okay, so you integrate from ln 3 to ln 5. Write down your fx. That will be e to the power of 2x minus 3ex plus 2e2x dx. So you use the substituting u equals to ex. So du will be ex dx, or dx equals to 1 over u du. So that's one thing. Second thing is that when you do the substitution, u equals to e to the power of ln 3, which is 3. U equals to e to the power of ln 5, which is 5. Therefore, this particular integration becomes 3, 5. 2u square minus 3u plus 2. You have 1 over u du. So this is integrate from 3 to 5. Perhaps I should write here. So u square minus 3u plus 2, that is u minus 1, u minus 2, yes. On top it will be 2u du. So now you do the partial fraction. You let u minus 1, u minus 2, 2u equals to this. A u minus 1 plus b u minus 2. So 2u equals to a u minus 2 plus b u minus 1. So when u equals to 2, b equals to 4. When u equals to 1, minus a equals to 2, or a equals to minus 2. Therefore, now you integrate from 3 to 5. 4 divided by u minus 2 minus 2 divided by u minus 1 du. So this particular integration gives you ln 4 ln u minus 2 minus 2 ln u minus 1, and then you evaluate from 3 to 5. So you have 4 ln 3 minus 2 ln 4 minus 4 ln 1 plus 2 ln 2. So 4 ln 1 is 0. So what you would have is 4 ln 3 minus 4 ln 2 plus 2 ln 2, or 4 ln 3 minus 2 ln 2. So you need to simplify to the end. So you can factorize out 2 ln 3 minus ln 2. So that is 2 ln 9 over 2. So you move the 2 up, it will be ln 9 square is 81, 2 square is 4. So that will be your answer. So that's the last question. Alright, thank you.